Welcome to the Phoenix Prosperity Podcast, where wealth meets legacy. Join your host, Tim Fergestad, as we explore the journeys of Phoenix's finest to success and beyond.
Hello, this is Tim Fergestad. Thank you for joining us. I'm very pleased to have Dave Dietrich with me here today. David is a fellow nerd. He's a PhD as well. He has a PhD in engineering management, a master's in manufacturing, as well as an MBA. He's a director of hardware sales and engineering support at PADT, is it?
Yep.
Which one?
PADT.
PADT. Okay. An industrial 3D printing expert, over 24 years of industry experience and over 17 years spent in research and development of industrial 3D printing. He holds 14 patents in the field of additive manufacturing and has published papers, given presentations, and published a book on additive manufacturing adoption in the industry. In addition, he holds production optimization expertise in Six Sigma and lean systems. The majority of David's technical and leadership experience is based on the aerospace industry, from Honeywell Aerospace and Boeing Research and Technology. Welcome to the show, Dave. That's a lot of great stuff.
Thanks, Tim. Thanks for having me. I really appreciate it.
So, how'd you get started in it? That seems like a great place to
start. It's an interesting story. Basically, the way that I really sort of got started in the industry is I became really excited about the technology. I was working at a company in St. Louis right out of undergrad, and I was doing design for police car and ambulance lighting and that sort of thing. So basically, we designed those low profile police cars that maybe you've gotten stopped by. You could barely see the top of them. So I was working on projects like that and doing some design work on that. And what I found through that process was we needed a way to be able to make some of the lenses for those light bars. We needed a way to make those, to prototype those, so that you could bring them and put them on the actual prototype product, and then see how it fits prior to us investing like $120,000 in injection mold tooling to do that. So we saw that as a way to burn down risk. This was a long time ago. This was way before really this industry was just barely getting started. So this was maybe 2001, 2002 timeframe. So it was
largely
very
plastics, simple plastics.
All plastics at that point. And so I reached out to a company in California. I was in St. Louis at the time, there was really no supplier for anything like that at that time in that area. And so I reached out to a company in California. That they were able to make these lenses that we were able to bring in, and we were able to basically confirm that design using that technology, and really burn down a lot of risk. And we were able to, make sure that the lenses fit correctly on the light bar and everything. So, it's for fairly small investment, and we were able to make sure that they were clear as well, which was kind of cool too. Okay. So it really kind of got me hooked on the technology in general. At the time, I was going to night school. I was getting my MBA at the time, and then I was working on a number of projects for that company. So then what came about was while I was in St. Louis, I was looking at sort of the job postings, looking for my next career jump from that. And I noticed that the Boeing Research and Technology at the time, Boeing Phantom Works in St. Louis, had a posting for a technician to come in and work in the lab that had all of this equipment. And I was just completely shocked. I didn't even realize that that existed within the St. Louis area at the time. And so I applied, and luckily enough, I was able to get hired into that role. And then within that role, I had access now to all of the different types of polymer printing technology, all under one roof. And Boeing was experimenting with this technology quite heavily, doing like wind tunnel models and all sorts of really cool applications.
You're geeking out with top of the line, cutting edge equipment.
Yeah, exactly. And so, part of my job was to come in and then start to understand it from a research and design standpoint. So understand kind of the nuances and what makes these machines tick, and why they're so effective generating wind tunnel tools or tooling, that could save days and thousands of dollars for Boeing. So I helped write specifications, worked on a number of different projects with learning each one of the technologies in incredible detail. I was like a kid in a playground at that time. It was incredible learning about it. it was really funny because in those days, no one really knew about 3D printing in general. It was more of known as rapid prototyping. And then all of a sudden, the small little consumer hobbyist printers started to come on the market. And then all of a sudden, it just exploded. Everyone knew about it, right? And I had like, you know, VPs from Boeing calling me up, asking me like, what are we doing in this area? And unbeknown to them that none of this was really even on their radar prior to it. So it kind of just exploded internally, and I just happened to be in the right place at the right time. I went on and pursued a number of sort of degrees while I was there to further my education, and then really drive deep into the technologies. I moved over from the polymers to the metals, and then started learning about the metals technologies as well. And so yeah, it was just, that's how I got started, and it just sort of snowballed from there. Went on and worked at Oak Ridge National Labs as a Boeing employee, learning even deeper into the technology. And then, came out here to Phoenix, took a job with Honeywell Aerospace, and worked with the folks there in this particular area as well. So that's kind of like in short summary how I all sort of gotten started in this, and it's been an exciting journey.
Okay, very cool. It started with prototype lenses, right?
Right.
Necessity is the mother of invention, right?
That's right. Yeah, that's right. Exactly.
And it was, I think, early 2000s. Yeah, we had some 3D printers. It was my first introduction to them as well. In the when I was in the genetics department at UW-Madison, we had a lot of nice equipment there. And in the biotech, we didn't have a strong need for it, at least at the level they were using it at now. Now you can print tissue.
Right. Yeah.
Right. And in the shape of an organ and all sorts of stuff. Now. Okay. Excellent. So give me a quick snapshot of PADT right now and what you're doing there and what the company does.
Yeah, so right now PADT is an interesting animal. It's a smaller company than what I've traditionally been used to working at in the large aerospace world. But PADT is a nice little niche company. We've been in business for 30 years here in the Phoenix area. We're located in Tempe in the ASU Research Park. And what PADT does is really they do sort of like three main thrust drivers for innovation. So we have a number of simulation software that we run, known as ANSYS, if you're familiar with that. It's actually the simulation software that does everything from thermodynamic transfer to CFD modeling and everything. So we have that software. As a suite, we have technical experts in that software, and then we also sell that software for ANSYS. For the main company. So that's one sort of leg of what we're doing. Okay. We also do 3D printing hardware. We have all of the 3D printers here. So we have experts that run the printers that we sell parts for other companies as a service bureau, but then we also sell the printers. So there's no piece of technology that we have here that we don't have experts in. Then we also end up selling them as well.
Okay. Is that a big manufacturing or shop part of the property?
It's a decent size. We do have it's a small, like I said, it's in the ASU Business Park. So we have a building here that actually PADT owns, and then we have several suites within that building, and so they're all sort of dedicated to do different things. We do sublease some of that out to other companies as well that are coming on and onboarding into an emerging field. So we do that, and then we also sell. We have scanners as 3D scanners, and we sell those, and then metals 3D printers, and so we do quite a bit of that work. In addition to all of that, it's kind of a nice ecosystem because we also then have another major aspect of PADT, which is the engineering services division. So anybody who an inventor looking to bring on a new product development, we have all of these simulation 3D printing tools, all this at our fingertips. So we naturally have a group that does nothing but sort of help other companies, whether it be a new tech startup, whether it be through an SBIR with a major company or something like that. We help them kind of secure the funding and then grow, and then ultimately help them achieve what they're looking for in new product design and development. So yeah, we kind of cover the whole gamut of innovation for companies in the area.
Okay, very cool. So I'm in the real estate industry now. I left the biomedical sciences, but I do still run into 3D printers.
Very good.
Do you have any experience with those big concrete ones that they
it's fascinating.
They seem pretty crude compared to what you do, but
they are. Well, I mean, but it's appropriate for the scale that they're doing, right? So
right.
Yeah, we don't sell the big concrete ones, but obviously I've been watching that space very clearly. It's very interesting. Every conference I go to, there's always someone talking about them, and it's quite interesting to see that grow. That's only been over the past 3 or 4-ish years of development, since that's sort of kicked off. But I see tremendous opportunity in that as well. You see like development homes in third world countries being used as an effective means for fabrication of homes at a much lower cost. You see it used in
well, as labor costs go up too. If you just need one guy to run the machine.
Yeah.
Right?
Yeah, one guy running the machine, but then you also don't have to have like, all of the extra labor of adding all of the other, like,
Right.
windows and light doors and like everything else, right? It kind of is
Right.
programmed to do it. I did talk to a Canadian company at one of the local conferences recently, who was looking to invest in that kind of technology. And he was mentioning that the big robots, the future of that whole industry will be robotic arms. That will sort of,
Right.
you move around. So you have like 4 or 5 different robot arms working on different sections of the house, as opposed to like one big gantry that
Right.
does like a whole sweeping motion. And that made a lot of sense to me. So I think you'll see that industry start evolving from the big frames doing really large kind of one-piece structures to then
Right.
multiple robots kind of being positioned all over the
I think I've seen that on the prefabs, right, where they build them in the warehouse and then they take them on site and assemble them.
Yeah. So I think that's kind of where that's going to naturally start moving. But yeah, it's an exciting field. I think there's a lot of opportunity to save some cost, and I don't know. It's really about the speed, putting up a house that way versus the traditional means.
Sure. So what's sort of in your niche, right, which you said is a lot of aerospace and such. Is there a lot of competition in that space?
Yeah,
in the space space?
In the space space. Yeah, most all of the major aerospace companies have been using this technology for a while now. I would say they probably all started back when I was, at Boeing. There was probably an equivalent of me somewhere at Lockheed or in Northrop and everywhere else, all sort of working, in parallel on these different projects. It has really kind of found a niche in that area because of a lot of the space requirements. So with 3D printing, you're able to really design parts that can't be made any other way. So with that, you can take advantage of the weight reduction. So you can build parts or design parts that really weighs a lot less than you can traditionally because of the inherent design complexity. So with that, you're able to sort of find a niche with aerospace, with flight, because every little pound saved, every little ounce saved is huge. So it naturally sort of gravitated to that industry from the beginning. But then you've since seen healthcare obviously come in and hip implants and cranial reconstructive surgeries and doing all sorts of really cool things in that field with 3D printing as well.
Right.
But yeah, that's sort of why it all kind of sort of coagulated around the aerospace industry first, is because of those those requirements on saving weight.
Okay. And historically, one of Arizona's biggest resources is our sunshine and weather. And so the aerospace industry used to be really big here. Is it still sort of a hub for a lot of this?
Oh yeah, there's still quite a few, there's quite a bit of work happening at Honeywell Aerospace. You have also Boeing Mesa sites here. You have a number of, other aspects too, Collins Aerospace. You have other sort of smaller companies in the aerospace field as well. So yeah, there's still a lot of aerospace here. It still drives the economy here in this region. Now, granted, it's kind of gotten less attention than obviously all the semiconductor work that's investment that's been poured in recently. But there's definitely still a need for aerospace and jobs in this community.
Okay, so if somebody listening wants to get better or learn more about 3D printing and all the different types, right? What do you suggest they do? Are there tips you could give them?
Yeah, absolutely. There are a number of, it's a broad topic. You could start by just educating yourself at one of the national conferences. There's a conference called Rapid, TCT Rapid, that happens every year. Unfortunately, it just happened in LA last month. So I had the opportunity to go there. It's a great conference to be able to showcase just a whole range of technologies across the spectrum. So some sort of conference attendance like that. There's also just local chapters and things too. It's almost become very commonplace to use just basic 3D printers in high school curriculum, middle school curriculum even. So
Right.
you see like sort of maker communities that are well established across the country now at this point. It's pretty amazing to see all of that grow up over the years. So there's tons of opportunities on maker communities. Just check your local groups that meet in this area. There's companies to internship at. There's PAT, of course. There's also A3D, which is another manufacturing company in the Valley that works in this space. Obviously, at all of the major aerospace companies, or even some of the healthcare companies around too, we have sold printers across the entire Valley, across the multiple states. So
Right.
there's a lot of different opportunities for people to get involved.
And do you have any sort of like educational events there?
Yeah, so we do have Nerdtoberfest, which is a huge thing that comes up for PDT. It's happening towards the end of October this year. We have it every year. It's an opportunity for people to come in and take a look at our printers, metal, polymer, and then also our scanning capability, and then also our evaluate our software capabilities and the things that I had mentioned earlier. It's kind of an open house event. It's a really good opportunity to come in and just sort of take a look at what we can do. So we typically have that once a year, and this year will be our 30th because it's our 30th year in business. So we're super excited about it.
Very cool. Very cool. So you mentioned the metal ones. You just reminded me, I think I was watching a Jay Leno show or special or something, because I know he's a big car guy, and he has all these antique cars that you can't get parts for anymore. So he has a number of printers. He just makes them. And I was wondering what the tolerances were for some of those materials now, how much pressure and how good they are.
Oh yeah, no, that's fantastic. Yeah, the metals printers are incredibly robust. That's largely a lot of the aerospace companies take advantage of those technologies. You're looking at like 99.997% density. So you're at kind of wrought properties of mechanically. So it would be the same. It would be better than even castings. If you were comparing it to castings, it would be more structurally sound than a casting. Wow. It would be more equivalent to like a wrought sheet or billet or something like that. It wouldn't quite be the capabilities of like a forging, for example. Okay. So anything that requires like forging level mechanical properties, you would have to use specialized equipment for that. You'd have to use electron beam technology for that. But for the most part, broadly speaking, you're looking at about equivalency of wrought kind of conditions.
Okay.
Yeah. So those technologies, it's a great application for what Jay Leno's doing. I could see, a lot of people affiliated with like the Barrett Jackson community, taking advantage of that. It's a lot of these older vehicles you can't find parts for. You don't even know where the tooling is. No, by the way, that's the same in the aerospace industry too. You don't know like where the tooling went for some aircraft that's like 70 years old. So it allows you to be able to fabricate parts that you can't find tooling for. Because it's just gone now. So yeah, I think there's a lot of opportunity there.
Okay, excellent. What's one of the biggest challenges you've had to overcome? And it could be a variety of things. You wrote a book too. Was that hard? I mean, there's a few things I'm sure you could touch on.
Additive manufacturing change management is the name of the book. I authored that, and I have a couple co-authors on that as well. It's really geared towards how to deploy this kind of technology within large organizations, and sort of the right steps to take, and kind of lessons learned from my past experience and some of the co-authors' past experiences on maybe what not to do when you're trying to deploy this technology. So yes, that was challenging, of course. I think overcoming challenges has been sort of the status quo for my career. This technology being a new technology, it's a disruptive. And what I talk about in the book quite a bit is how trying to introduce a brand new technology into a traditional fabrication, kind of staunch conservative sort of world of aerospace fabrication is a challenge inherently, because you have a lot of people. It's a lot easier for some of the people, like the chief engineers and things, that a lot easier for them to say no than yes as you try to deploy this technology onto aircraft. And so you have to come with data. You have to come with a lot of data that showcases the mechanical properties that you were talking about earlier, and showcases that it does have the capability to reach the requirements necessary to make this hardware. So my whole career, I've been fighting against that, right? So it's a new technology. You have to be an advocate. You have to be almost
Right.
like, like you have to be an advocate for the technology, a disciple of it, if you want to think of it that way. I
Yeah,
don't know.
it's champion.
Yeah, you have to constantly do that. But it's been rewarding. It's like I said, the best thing that I can see over the years since I started doing this in 2004 is I've seen it just explode, and I've seen it grow, and I've seen it actually applied and adopted, and to me that's incredibly rewarding.
Excellent. Okay, and what do you see coming up like in the next year or so in the industry, or just for you personally? What do you have anything exciting coming up?
Oh goodness, yeah, we've got there's so many different projects that we have going on. I think that there's a lot of opportunity from a technical standpoint. There's going to be more materials that are going to be available. So right now we typically have just sort of metals and polymers. Now there's like ceramic blends of materials that now we can do. So you're looking more, ceramics are starting to open up as a material that we can start using. I think you'll see machines get larger, you'll see them get faster, and you'll see them, become even more commonplace within industry. So from a technological standpoint, I see that that's kind of a natural progression. I feel like also the designs will become more elegant and they'll become even more complex. Software has always been kind of a bit of an impediment because it's the processing power needed to design some of these really intricate, complicated geometries has always been there to hold it back a bit. With the computing power increases, that's now sort of changing too. It's kind of funny that you can actually physically fabricate something more complex than you can actually design it, like with the design tools. And so
Wow.
that's kind of now
Well, that gets into like designing your own processors now, right? I mean, you can mix your insulators and your conductors and make your own operational amplifiers probably pretty easily now.
Right. Yeah, you can take things now to another design level that you couldn't before. And then that's now coupled with advances in the material science. So really it's all just sort of optimizing to a level where you're going to be able to really take advantage of the technology, what it can do from the design standpoint, from the mechanical property standpoint. You're going to be able to really create parts that you cannot manufacture any other way, and that's when the technology wins, frankly. So that's how I see the technology kind of moving. From a personal standpoint, I see we continue to grow here at PADT in terms of what we can do for our customers, and being able to sort of take on new projects. I think we've got a lot of opportunity on different sort of technologies that we've been working on. But from a personal standpoint, yeah, I'm just I'm trying to get my kids through college, right?
Right.
So, but like most people, but it's going to be fun. It's going to be a wild ride. Buckle up as we keep driving this technology forward.
Right. Right. Okay. Well, thank you very much, Dave. So we talked a lot of shop, really. We didn't talk a lot about you and sort of you have kids in college, for example.
Right.
Reflecting back on your journey and your success and building wealth and stuff in your career, what do you wish you would have known sooner or earlier?
Oh, that's a great question. Yeah, what I wish I would have known sooner. Yeah, I would say probably a lot of it comes down to making connections and understanding the value of networking and building connections. When I was earlier in my career, I was just sort of the typical stereotypical sort of engineer, right? Just put on the blinders and solve problems, that sort of thing.
That's me, nerd. I like my stuff. I don't want to go talk to people. I want to go play with my toys.
Yeah, exactly. I don't need to talk to that person because that person's got his own agenda and I just got my own thing. That was something that I wish somebody, I guess, would have come to me at the time and be like, no, look, open it up, start talking to everybody, engage with others in this technology, don't just get lost in the data. And so I think that's something that I don't think I would be unique in that. I think there's a lot of folks that sort of come out of engineering school and they kind of go into that kind of mode set.
But I imagine your MBA helped you expand.
It did a little bit. Yeah. I had to do a presentation with every class, right? That was actually that was a gift. It was a curse of the time for me, but it was a gift in thinking back about it.
Right.
And so there was a lot to that was very helpful. Yeah, I would say that's probably what I would go back, and if I could tell myself earlier, I would say, hey, just embrace this, like go ahead and network out. get involved in the community, get involved with, helping out, teaching the next level. That's something that I've been working on. We now have a whole certification program for teaching the teachers. So we have like community college professors come in and we just now kicked this program off where they're going to come in and receive training from us for like a week, and then they'll become quote unquote certified, where then they can start using the machines and start distributing out, teaching how to use these machines effectively at the community college level. Before that certification existed, it was kind of like an ad hoc approach to teaching this. We now will have an official sort of certification around it. I've always invested my time trying to go in and chat with like high school students and about this technology, where you could take your career in this field, that sort of thing. So yeah, now my career is mainly now focused more on giving back into the community and trying to make sure that next generation comes up, in this technology and drives it forward even more.
Excellent. Yeah, that's classic hero's journey stuff. Go out, go accomplish the thing, then come back and share it with people, right? And also, I think some of the biggest advances, some of the most successful people I know, they level up when they start. They dial in their expertise, and then they take a step back and see how now can I spread this across different industries and different groups and so forth. Yeah.
I will say that I did quite a bit of graduate level teaching. So I was teaching at various Lean and Six Sigma courses and additive work and even engineering management courses at various different universities. And I think that was a really eye-opening experience as well, because as like an adjunct professor, right? Because you get to see things in a whole different world, and you now are self-checking yourself. Like, am I communicating this appropriately? Like, are they getting what I'm saying? Like, you're always like, you teach yourself how to teach, right? And so you get a better understanding when you have to teach it and how to translate it to other industries and fields, right? Right, exactly. So I think that was also something that I would highly recommend for that next PhD student that's working on their little research project in this field, to really adopt and really lean into that whole teaching element, because it was really helpful for me as well. Oh, I'm sure. Good advice. Another piece of gold there. Thanks, Dave. All right. Well, thank you so much for your time today and for sharing some tips and insights in the 3D industry and your own path. If people would like to connect with you, what should they do? Yep, I'm on LinkedIn. You can always connect with me at Dave Dietrich. So yeah, feel free to reach out through that mode of connection. And I check it as much as I can. I'm not on it all the time, but I do check it as much as I can. So I'll promise to get back with you. All right. Thank you very much for watching. Thank you very much, Dave Dietrich, for joining me today. Thanks, Tim. I appreciate it. All right.
Inspired by our guests? Visit phoenixprosperitypodcast.com/guest and join us on the show and share your success story with Tim. The spotlight awaits.